A very good morning, everyone. A very good morning, ladies and gentlemen. I warmly welcome you all to the Research Week 2024 once again. So today marks the last day of the Research Week, consisting of 8 days, including today. And over the past 8 days, we have been engaging in sound academic discourses and immersing ourselves in the wisdom of the research outcomes. So now we are at the very latter part of the Research Week, and today's lineup would be as interesting and interactive as it has been throughout this Research Week 2024. But before we move on with today's lineup, let me remind the financial pillars of the Research Week 2024. So we thank all the sponsors for their financial assistance who recognize the importance of researching. Specifically, we thank Commercial Bank, our platinum sponsor, BAM Green and INSEE EcoCycle, our silver sponsors, Swisstech Aluminium, Alumex PLC and Tokyo Cement, our bronze sponsors, and food and beverage sponsors of the event. So we, Research Week 2024 Organizing Committee, truly appreciate their generous support. Right, now let's take a quick look at the messages of our sponsors.
In Sri Lanka's financial landscape, Commercial Bank stands out as the trailblazer in sustainability. As the country's first carbon-neutral bank, our commitment goes beyond buzzwords. It influences our actions and services. In this moment, we unveil a fresh identity, symbolizing our unwavering pledge for a sustainable tomorrow. Join us by making conscious banking choices a seamless part of your financial experience. Commercial Bank, creating a sustainable future.
Welcome to BAM Green, the pioneers in domestic and industrial solar energy systems in Sri Lanka, together with exclusive warranties and outstanding after-sales services. BAM Green offers you a wide range of solar energy solutions with high-quality European products, together with exclusive warranties and outstanding after-sales services. Our engineering, technical and customer care teams will take care of your projects from start to completion. From inspections, system designs and installations of solar PV systems, wind power and hybrid solutions, we handle complete systems integrations. Talk to one of our solar consultants to discuss your project and help save our earth. Go green with BAM Green.
INSEE has been operating its waste management arm, INSEE EcoCycle, since 2003. With global expertise in waste management, at INSEE EcoCycle, we provide sustainable environmental solutions to manage industrial waste of your organization. We are the premium waste solution services provider in Sri Lanka with the scheduled waste management license to collect, transport, process and eliminate hazardous and non-hazardous industrial waste safely. We act in line with the National Environmental Protection and Quality Regulations while complying with international health and safety standards. Being part of the region's largest waste management business, we provide a multitude of services to waste generators, from waste profiling to waste treatment. We currently extend us along with government institutions in Sri Lanka, refines chemical and physical composition with the previously agreed specifications. Our pre-processing facility treats different waste streams using a series of customized technologies to produce a homogeneous material compatible for co-processing in the cement kiln. EcoCycle's waste analytical laboratories in Putlam and Katunayaka are built to strengthen the pre-processing quality control of the waste materials fed country. INSEE EcoCycle is awarded numerous local and global certifications. By joining hands with us, you contribute to the country's sustainable development and to make Sri Lanka waste-free. Together, we strive to protect, preserve, and restore the environment for the next generation.
Our journey began 30 years ago with a larger-than-life vision. we expanded, adapted, and evolved to become Sri Lanka's foremost aluminium extrusion manufacturer. With continuous innovation, we were able to provide a lighter, stronger, and flexible product that offered infinite solutions for the future. We were recognized and we received international certifications to become the most trusted aluminium brand in Sri Lanka. As a leading provider of best-in-class commercial, industrial, residential, and architectural aluminium extrusion profiles in Sri Lanka, we have shaped industries around the world. Today, we offer a range of breakthrough innovations with our expert capabilities and future-tested technology in the world of aluminium manufacturing. While we achieve our goals, we have a responsibility to our future. Today, with a family of 950 members, our journey has a greater vision. We carry the responsibility to save Mother Nature, to give back to one who gave us everything. Saving millions of trees already. We continue our battle against the carbon footprint. Aluminium is the metal of the future, and every day we strive to make aluminium part of the solution to the greatest challenge of our time. We are Alumex.
Right. With that, I believe we are all set to begin our very first session of the day. So the first session of the day would be the 32nd installment of the inaugural lecture series hosted by the Faculty of Graduate Studies, University of Moratuwa. Right, with that enlightenment about the inaugural lectures, now let's move on to the inaugural lecture, the 32nd inaugural lecture of the University of Moratuwa. So to facilitate today's session, let me invite Mr. V. Silva, Head of the Department of Material Science, Faculty of Engineering of University of Moratuwa, onto the stage. Over to you, sir.
Good morning, everyone. Those who are physically present and those who are online. I have the privilege to introduce Professor G.I.P. de Silva in his inaugural lecture. G.I.P. de Silva entered the University of Moratuwa as an undergraduate in 1998. So I didn't use professor there because I should not be saying Professor G.I.P. de Silva entered the university as an undergraduate. So anyway, I have the right to call him by the first name because he is one of my students. And he obtained his bachelor's degree, Bachelor of the Science of Engineering degree, in the year 2003, after about 5 years, because of there were certain issues in the university. And then he proceeded to obtain his Master of Philosophy also from the Department of Material Science and Engineering in the year 2006. And then from there, he proceeded to Japan and he obtained his Doctor of Philosophy degree in the year of 2009 from Kochi University of Japan. On his return to Sri Lanka, he was appointed as the senior lecturer position in the year 2010 and promoted to senior lecturer grade 1 in the year 2016. And while in service, he was promoted to the post of professor in the year 2021, in December 2021. His research areas are vast, but the two main areas which we can highlight is metallurgy and superconductors. He has obtained 2 patents up to now, and he has also authored 2 books related to his field. He has been an international research fellow at University of Wollongong, Australia in the year 2017. While I am inviting Professor G.I.P. Silva for his inaugural lecture, I wish him all the best. Thank you.
Good morning, all of you. Thank you, sir, for your kind introduction about me. Dean, Faculty of Engineering, Dean, Faculty of Graduate Studies, distinguished invitees who have joined the event physically and online mode, dear colleagues and my dear students. Today, I feel honored and privileged to address this distinguished gathering as part of the inaugural lecture series organized by the FGS, especially during this research week. So first, I would like to take this opportunity to express my gratitude to all the individuals who have supported me throughout my academic journey. In fact, I'm standing here today with this Professor Clark because of the guidance, direction, and advice I received from them. So I would like to respectfully mention my parents who were always by my side, offering their dedication and valuable guidance. Unfortunately, they are no longer with us to listen this talk today. My two sisters, both are school teachers, also played a supporting role in various ways during this academic career. And also, my loving wife, who is a senior lecturer attached to the Faculty of Engineering KDU, is with me during all the ups and downs in my life. And also, I cannot forget my little girl, who is just 11 years old, being the biggest comfort in my life. When I talk about my primary and secondary education at Dharmashoka College, Ambalangoda, that is the place which molded me to become who I am today. So during my school years, actually I engaged in variety of extracurricular activities, including stage dramas, serving as the compeer for school functions, and also leading the school debating team. So, frankly speaking, like all other children, I also had a dream to become a lawyer. So in the meantime, I met an influencing character, that is my O-level mathematics teacher, Mrs. Inaya Mersuk. So who led me to a different direction. As a result, I ended up selecting the physical science stream for my A-levels. So I would like to take this opportunity to respectfully remember her today. So, moving on to my university education. I entered the University of Moratuwa as an undergraduate student in 1998. So in this occasion, I would like to especially remember Professor Nanda Munasinghe, who was attached to the Department of Material Science and Engineering. So I would say his dedication and commitment to university work, and also his engaging lecturing style greatly inspired me to pursue a career as a university lecturer. And also, he is the supervisor of my MPhil research. And finally, I would like to extend my gratitude to my PhD supervisor, Maeda Sensei, for his encouragements and valuable guidance throughout my research and life in Japan. So, with that remark, today I am going to start my inaugural lecture on significance of aluminum alloys in modern engineering applications. So, when we look at the global demand for the aluminum alloys, so the production of aluminum alloys has been steadily increasing today. The global production of aluminum alloys is around 68.5 million metric tons in 2022, which is 2.6 times that in 2002. So as you can see in this figure, so you can see the significant improvement in the usage of aluminum alloys. So when we talk about the manufacturing of aluminum alloys, the largest manufacturing country for aluminum alloy is China, accounting for approximately 60% of global production in 2022. So as you know, the aluminum is fully recyclable without losing its quality, making it a highly valuable, sustainable material. So we say that is the green metal. So when we look at the aluminum alloy designation system, that is established by the International Alloy Designation System, IADS, based on the classification developed by the Aluminium Association of the United States. So here I am not going to take this moment for a long lecture, but briefly I explain you. So simply, you know what is mean by alloy? Alloy means, so you know about pure aluminum. Pure aluminum, you know, that is ductile material which has higher thermal and electrical conductivity, and also which has FCC crystal structure. So when we mixed some other alloying, some other elements with the aluminum, then we say that is an alloy. So basically, in aluminum alloys, we can see a series of aluminum alloys. For example, the aluminum 2 series means that is aluminum copper alloy. So here, so with that, I move to explain you this 4-digit system briefly. So what is aluminium 6063? So as we know, for example, so why I select aluminium 6063 especially? Because, so you know, in normal the door window frames, some structural applications, right? The bars with various sections. So all the things are produced with aluminium 6063. So locally, we can see the established companies like Alumix, Swistech, Lanka Aluminium. They produce aluminium components with this alloy. And here, as I mentioned, the first digit 6 means the aluminium, magnesium, and silicon alloy. And the second digit indicates the originality. The 0 means it's original alloy. When we do some modifications, it takes some other numbers. And also the last 2 digits, 63, means the specific alloy contents for this specific alloy, that is silicon 0.2 to 0.6 and magnesium 0.45 to 0.9 weight%. And in addition, there are some other minor elements like iron and copper. And T5 is the heat treatment process. That is the process applying in the companies like Alumix, Swistech when they are producing the extrusions. So, with that, I am moving to discuss about the superior properties of aluminium alloys. It's recyclable. Aluminium can be recycled over and over without any degradation or loss of its original characteristics. That is the specialty of aluminium alloys. And also, aluminium has significant scrap value, making it not only environmentally friendly because of the recyclability, and also it's cost effective relative to other elements. And especially, recycled aluminium takes only 5% of the energy necessary to produce the virgin aluminium. That is very important point in aluminium industry. And also regarding the lightweight, as you know, that is approximately 1/3 of steel. And because of its lightweight, aluminium alloy profiles advantage, its properties, the advantage translates into fuel efficiency, product portability, and economical shipping cost. And also that is extensively used in sporting equipment. And as you can see in this figure, so here the truck trailer, for the truck trailers, the aluminium 5 series is used for the truck trailers. And especially its high strength to weight ratio. So that is leading for the modern aluminium alloy, due to their high strength to weight ratio, have been widely used in many structural components, especially for aviation and automobile industries. And as you can see here, in this figure, so you can see for the various parts of the aircraft, right? So how the aluminium alloys are used, especially aluminium 2 and 7 series. So what are they? the aluminium 2, that is aluminium copper, and 7 means aluminium zinc. So that is, you can see how these alloys, aluminium alloys used in aircraft components. And also, when we compare the aluminium alloys strength to weight ratio with the steel, alloy steel, it has significantly higher strength to weight ratio. And when compared with titanium alloys, of course titanium alloys have high strength to weight ratio, but it's expensive. And regarding the corrosion resistance, so it's very simple thing. So you know the aluminium form a thin oxide layer that is both durable and corrosion resistant, and scratching through the protective oxide layer also reforms a new layer. So because of this characteristic, actually in marine construction and shipbuilding, particularly in the construction of hulls, superstructures, and deck panels of ships, due to their high strength to weight ratio and corrosion resistant, aluminium alloys used for various parts of the ships and also in marine structures. So especially the aluminium alloys 5 and 6 series are employed in these applications. And as you can see, there are some other significant properties, thermal conductivity. So we use extruded aluminium heat sinks for the applications such as electronics, and it's a non-toxic material and also non-magnetic. So with that, actually I'm moving to explain you why, so the strengthening mechanisms of aluminium alloys. So it means, so why compared to pure aluminium, why aluminium alloys has higher strength and hardness. So that is due to the strengthening mechanisms applying to the aluminium alloys. Basically, it has, so we are applying 4 strengthening mechanisms. In all these mechanisms, the theory behind that is making the barrier for the dislocation movement. Making the barrier for dislocation movements. So, the first one, the solid, that is solid solution strengthening. What is solid solution strengthening? So simply I can say, we introduce solute atoms to the pure aluminium structure having FCC crystal structure, which forms lattice distortion there. Lattice distortion in the aluminium matrix, which creating a barrier for dislocation movement. Dislocation means that is a half atomic plane, making a barrier for the dislocation movement. And second phase is strengthening. In there, basically 2 types, the particle reinforced aluminium matrix composites, adding, for example, adding 0.7 weight% titanium boron particles, the strength of aluminium, silicon, copper alloys increased by 22.3%. And precipitation hardening, that is in aluminium 6.63 alloy, magnesium silicide precipitates, creating the barrier for dislocation movement. In all these cases, the precipitates are making barrier for the dislocation movement. That is how it gaining this strengthening effect. And also application of the properly designed heat treatment processes, including homogenizing. So we can make fine grain structure. It means the smaller equiax grains are formed in the structure. So more grain boundaries have a stronger blocking effect on dislocation. More smaller grain means more grain boundaries, making the barrier for the dislocation movement. And also introducing, the fourth mechanism is during the metal forming processes such as forging, rolling, these processes, the strengthening effect is gained due to increase of dislocation density. I said dislocation means half atomic plane. So during this mechanical processing, the dislocation densities increase. That is making a barrier for individual dislocations. So these are the, mechanisms that we make it high strength. And I briefly explain you the precipitation hardening process I highlighted here. The precipitation hardening. So how does the aluminium 6.63 gain the strength that is nearly 3 times higher than pure aluminium? So here, the alpha means the solid solution of all solute atoms. Here the aluminium, magnesium, silicon, copper, iron, all are in a solid solution. We say that is alpha. Beta means the precipitates formed in the matrix. That is beta. So here in aluminium 6.63, especially the magnesium silicide is the precipitate responsible for gaining the strength and hardness. And in addition, some other precipitates are formed. These are iron-based precipitates. Actually, iron is an impurity here. So it is required to minimize the formation of iron-based precipitates. And here you can see in this aging process, basically 3 stages: solution treatment, quenching, and aging treatment. So, as you can see here, initially during the solution treatment, all the precipitates segregated in the grain boundaries are dissolved in the structure during the solution treatment. And after the quenching, maybe air quenching or water quenching is applying. So then we move to the aging treatment. Simply we can say that is normally heating up to the temperature 200, 210 and keeping that temperature around 1.5 hours. So this is the heat treatment applying in the local aluminium extrusion manufacturing companies. And here you can see in this same image how the precipitates, actually these are magnesium silicide precipitates with the size of around 30-40 nanometers are distributing in the structure, in the matrix. So these particles, as I explained you, these are the precipitates making the barrier for dislocation movement and making the strengthening effect. And with that explanation, I am moving to explain you some of the significant research outcomes of my research work. So here, two-step precipitation hardening treatment was developed for the local industry. This is collaborative research conducted with the Alumex Private Limited. So basically, here what is the research finding? So as you can see here, the single-step edge hardening treatment applied in the industry. So this is the aging treatment I explained you here. The aging treatment in the last part of the heat treatment. And here, all right, okay, thank you. Yes, so this is the aging treatment. This is the aging treatment I discussed. So I am talking about that treatment. So here, as you can see, the hardness and strength gain for the extrusion 47 because hardness and strength 200, nearly 230 megapascal. And the total time period for this heat treatment, that is 270 minutes. So with the development of two-step edge hardening process, the total time period is reduced up to 220 minutes. That is the significant finding in this research. 50 minutes reduction in the aging time period. So with that, the industry can increase the production rate and also reduce the energy cost. And the mechanical properties also increased with the significant level, as you can see here, the hardness and strength. And so this is also another research I conducted, development of mathematical model to relate the aging parameters to hardness and tensile strength of aluminium 6063. So I am happy today because the research student conducted this research with my supervision is here today, Mr. Sivanujan. So in this research, actually, as I said previously, in aging parameters, what are the aging parameters? The aging time and the temperature. Aging time and the temperature. So for a given combination of aging time and temperature, we can achieve certain level of mechanical properties, strength and hardness. But it was revealed that there is no research work conducted to explain comprehensively how the precipitate size distribution affect these mechanical properties. The comprehensive research work. and also to find the best combination of aging parameters to find the best combination of aging parameters to achieve the required level of mechanical properties. It is required to find a mathematical model. For example, you know, in Alumex, they are using the aging, the combination, their combination for the aging time and temperature, they use since a long time ago, right? And in other, you know, aluminium manufacturing companies also, they do slightly change that without any scientific basis. So, for example, here you can see in this model, to find the best combination of aging parameters, we can see, okay, here the tensile strength and hardness. So we required the strength 210 megapascal and hardness 65. To achieve this combination, through this mathematical model, we can find the required combination of aging parameters, the best combination, 188 centigrade aging temperature and 160 minutes of aging time. So here the categorical predictor model equations were complemented by Python to find the most effective combination of aging parameters for the required hardness and strength. And also we recently published these findings in this journal. And now I am moving to discuss the superior applications and innovations of the aluminium alloys. So as you may know, the Haifa International World Headquarters, the global non-profit organization is Arkansas, USA, working to eradicate poverty and hunger. So this comprised of extruded aluminium 6082 components on the building's exterior, block excess sunlight to reduce the solar heat gain, and light sheaths made from extruded aluminium alloy subframing were installed inside the outer walls to bounce light up, redirecting natural light to reflect it further into the building. Nice architectural design using the aluminium 6063. And here I need to stress the point, the 97% of the project's aluminium components contain recycled aluminium alloys. 97% of project aluminium components. And AT&T Stadium, it has, as you can see here, it's uncommon architecture design. The retractable roof stadium in Texas, USA, it was completed in 2009. This $1 billion stadium seats 80,000 fans and features a quarter-mile-long retractable roof. Incorporates more than 1.2 million pounds of aluminium extrusions into the glass curtain wall and movable end-zone door systems. A total of 61 new extrusion dies were used to create the extruded aluminium framing using aluminium 6063. And also, this is one of the significant innovation, the International Space Station, ISS. the largest technology intensive construction project ever undertaken by humankind that was assembled in low Earth orbit by collaboration of 5 international space agencies. The primary purpose is to perform space environment research in 6 laboratories there. The ISS extruded integrated truss sections span the length of a football field, that is 310 feet. And ISS takes the advantage of aluminium extrusions, lightweight, corrosion resistant, and especially the critical structural strength in the extreme cold of space. So here the 16, as you can see, the 16 extruded aluminium 6063 truss segment from the structural framework that houses the cooling systems and photovoltaic arrays that power 6 laboratories. And also the regarding the automobile industry, the 2021 Tesla Model S car, I think Dr. Gamage is here, so he knows about this, right? So here the significant feature is the boosting 1020 horsepower from 3 onboard electric motors and is capable of reaching 0 to 60 miles per hour in 2 seconds. So here the significant feature is the aluminium 606 alloy extrusions bonded together with a hot cure adhesive to form the chassis weighing to just 208 kilograms. It's a lightweight. The space frame is comprised of 70% extruded aluminium components, which enables better fuel economy and nearly twice the impact toughness as steel. And with that part, actually, I am moving to the, the 3D printing. That is one of the emerging technologies today we discussed. The 3D printing of aluminium alloys. So, as you may know, the 3D printed aluminium alloy components are built up by layer with a high level of design freedom and manufacturing flexibility. So, here especially the aluminium, silicon, magnesium alloy, that is also aluminium, special aluminium alloy that is used for the 3D printing. So here there are a lot of 3D printing methods used for aluminium alloys, but here I just mentioned just 2 methods, the powder bed fusion. In that case, it's very simple mechanism. So here, the aluminium powder yes. So here, as you can see, the aluminium is used, aluminium alloy is used as a powder here. That is stored in this part, this storage, and this is a movable part. When it is moving upward, the alloy, the powder is coming out, and that is moving to this section with the powder roller. And here we give some space, specific, space for this powder, and using a heat source, maybe laser or electron beam, the aluminum powder is fused together and making solidify. So here the powder, we focus the laser beam to specifically for the area that we need to make solidify. And making one layer, and with the movement of this section, with the that is moving downward, again the same thing happen, right? The powder, new powder coming from this section, and again making solidify by fusion process. That is powder bed fusion. And the binder jetting means the same method, the only difference is instead of the heat source, here we use liquid binder to bind the aluminum particles together and making it solidify. That is binder jetting method. So this is the last part of my inaugural lecture, the nanotechnology in aluminum alloy enhancement, the role of nanotechnology. So there are, various, the nanotechnology is involving in various ways for the aluminum alloy enhancement, but here I focus on the strengthening mechanism part. The particle reinforcement. So how to do this? Incorporating hard nanoparticles such as aluminum oxide, silicon carbide into aluminum matrix. These nanoparticles act as a reinforcements, again as I explained you, the blocking the movement of dislocations and the significantly strengthening the material. For example, the adding nanoparticles of alumina to an aluminum alloy can increase its strength from 300 megapascal to over 600 megapascal, more than double, making it suitable for aircraft fuselage construction. And grain boundary strengthening, this is another strengthening mechanism. Previously I explained you. So here, the role of nanotechnology is the nanoparticles are introduced to aluminum lithium alloys to refine the grain structure of the material. So especially it improves the high strength and more fatigue resistant of the component. So this is one of the examples. The Airbus A350 features extensive use of nanotechnology, enhanced aluminum lithium alloy in its fuselage and wing structures. And also improving the thermal conductivity and resistant to thermal degradation. So here, the incorporating titanium carbide nanoparticles into aluminum alloys can improve their thermal conductivity up to 15%. That is a significant improvement, while increasing their resistance to thermal degradation at elevated temperatures. So as you can see here, in this same analysis, the titanium carbide particles we can see in the matrix of the alloy. And especially this is used for high temperature applications in electronic industries. And regarding the wear resistance, so how to improve the wear resistance with application of nanotechnology? Inclusion of ultra hard nanoparticles such as silicon carbide or boron carbide in aluminum matrix. These particles provide a protective layer within the aluminum matrix, acting as a barrier against the abrasive forces. So as this figure illustrates, so you can see this is the alloy without introducing the nanoparticles. So after introduction of the nano silicon carbide particles, we can see how it bonded around the aluminum alloy particles, and making the abrasion resistant. So with that, the aluminum alloy is reinforced with silicon carbide nanoparticles, exhibits up to 30% reduction in wear rates compared to traditional aluminum alloys. It's a significant improvement. So, this is the end of my inaugural lecture. Thank you all again for being with me here. Thank you.
Right. Thank you, Professor, for that comprehensive, detailed and informative session. It's quite interesting to see how aluminium is being used in different industries and how these industries is using the different characteristics of aluminium in the modern world. It's quite interesting to see and know that we could use aluminium in these ways. So once again, we truly appreciate, sir, you sharing your expertise with us today. And ladies and gentlemen, now it's a time to present the lecture memento to our dear Professor De Silva. So now I would like to invite Professor Jagat Manatunga, Dean Faculty of Engineering, to present the lecture memento to Professor De Silva. Thank you, sir. Once again, we thank Professor De Silva for sharing his knowledge with us today. And I also take this opportunity to thank the sponsors of the inaugural lecture series hosted by the Department of Graduate Studies. So Cargill's Private Limited, our event sponsor. Daily FD, our print media sponsor. Sri Lankan Scientists, our social media sponsors, for their valuable support. So we also thank everyone joined us physically as well as online for the 32nd installment of the inaugural lecture series hosted by the Faculty of Graduate Studies, University of Moratuwa.